Now that we've run a test for independence by hand and with the calculator, we want to be able to do the same but for a test for homogeneity. But remember, a test for homogeneity really isn't that different from a test for independence. The only difference is in step 1 when you write your hypotheses and in the last step when you write your conclusion. So we have a study of the television viewing habits of children. A developmental psychologist selects a random sample of first graders. Each child is asked which of the following TV programs they like best: The Lone Ranger, Sesame Street, or The Simpsons. Computer outputs for the tests for homogeneity on the results of the survey are below. And as I recall from this particular study, I think they showed them one of each of those shows. So they showed the kids a Lone Ranger, a Sesame Street, and a Simpsons, and then asked them which one they liked best. All right, now I've kind of highlighted these outputs really thoroughly so you can see all the differences. And the really hard thing to spot is the difference in count and expected count. So here in StatCrunch it says count is on top, expected count is on bottom. That's your cell format. So when you look down here at these cells, you have the count, the observed value, in other words, on the top. So you observe 50 boys like Lone Ranger, 30 boys like Sesame Street, 20 boys like The Simpsons. And then over here down below you have the observed counts for the girls, 50, 80, and 70. Then below that you have your expected values, right? Those are those expected frequencies, which you could find yourself by multiplying 100 times 100 divided by 300, or 100 times 110 divided by 300, and so on. But we don't have to do it by hand because the computer outputs have done all the big heavy lifting for us. Now, Minitab does the same thing. Minitab writes right here what they're saying. The expected counts are printed below the observed counts. So that means you have observed counts on top. That's the 50, 30, 20. The expected counts below it. And then observed counts for the girls right here. And notice that I have to write somewhere that group 1 was boys. In this particular one, it was kind of obvious because StatCrunch makes it obvious, because StatCrunch tells you which group is boys and which group is girls. Minitab doesn't do that. It just tells you group 1 and group 2. So if that's the case and you're given Minitab, then somewhere I'll have to write which group is which. All right, then over here on the right hand margin you have your totals. Also down below you have your totals. So these are the row totals, these are the column totals. StatCrunch has the same. And then in the bottom right hand corner in that purple box is your grand total, right? And then I've also noticed the chi-square statistic right there. That's your test statistic. Your p-value of 0.000 and your degrees of freedom is 2. All right, so let's answer some questions. How many first graders were surveyed in total? Well, that's the purple box. That's 300. So the n for the total is 300. How many boys were surveyed is 100. That's this little aqua box right here, which by the way means there were 200 girls surveyed, right, if there's 300 total. All right, then I want to find the contingency table of observed values. So what I'm asking to do there is to take those yellow rows that are separated and make one table out of them. Instead of writing this as one conglomerated table with 2 rows, write just one table with one set of rows. So that would be the yellow table, the observed values, 50, 30, 20, 50, 80, 70. Those are the observed values right there for the yellow. Then right below it, I want the expected values, which is the orange. That's 33.33, 36.67, and 30 for the boys. And then for the girls, 66.67, 73.33, and 60. Now the totals for both sets are 100 and 200. That's why these say 100, 200, 300, 100, 200, 300. And then the column totals are 100, 110, and 90 for both sets. For example, 30 and 60 makes 90. 20 and 70 makes 90. So it's going to add up to 90 no matter what. 50 and 50 add up to 100. 33 and 66 with their respective decimals add up to 100, and so on. So with these two problems, you're showing that you know how to read these outputs and break them up into the 2 separate tables that you need. All right, now why would this be a test of homogeneity? Homogeneity is when you have 2 separate groups, in this case boys and girls, and you're asking them about one response variable, their favorite TV show. Now that one response variable can take on 3 different values: Lone Ranger, Simpsons, and Sesame Street, but nevertheless it's one response variable. All right, now how to calculate that degrees of freedom. They said the degrees of freedom was 2. Where does that come from? Well, if you remember back here in the test, I remind you, oops, back in the test, here it is. Degrees of freedom is r minus 1 times c minus 1. So let's go calculate that. All right, the number of rows, take away 1, times the number of columns, take away 1. Well, there's 2 rows for boys and girls, 2 rows. And then there's 3 columns. So that's 2 take away 1 times 3 take away 1. 2 take away 1 is 1. 3 take away 1 is 2. And that gets us 2 for our degrees of freedom. And there's how to calculate it. Now, the real test comes here. Do the boys' preferences for these TV programs, differ significantly from the girls' preferences? Conduct a hypothesis test using the p-value method and a 0.05 level of significance showing all steps. So notice we're not mentioning independence. This isn't a test of independence. This is, do the boys' preferences for proportional preferences for the TV shows differ from the girls' programmable preferences. Boy, I'm not going to be able to say that 3 times fast. All right, so let me write up the hypotheses. They're going to be different than what we had before because we're going to involve proportions. All right, there's step 1. So we're going to set up that the boys who prefer Lone Ranger is equal to the proportion of girls who prefer Lone Ranger. Then the boys who prefer Sesame Street is equal to the proportion of girls who prefer Sesame Street. And the boys who prefer The Simpsons is equal to the proportion of the girls that prefer The Simpsons. In other words, I'm saying that there is a homogeneity, an equalness amongst the proportions for these different groups. So I think the proportions for each Lone Ranger category are the same. The proportion for each Sesame Street category are the same, and so on. The other way to do this, there is another way to do it, would be to say the proportion of boys who prefer Lone Ranger is equal to the proportion of boys that prefer Sesame Street, which is equal to the proportion of boys that prefer The Simpsons. In other words, you work down these 3 and set these 3 equal to each other, and then these 3 for the girls equal to each other. That is also a valid way to construct these hypotheses. All right, step 2 would be everybody's favorite step, alpha. Alpha is equal to 0.05 right here, 0.05. All right, step 3, we need to have our chi-square statistic. But remember, we're just going to get that from the calculator computer output. We're not going to do it by hand. And that's the part that's in the red right here. There we have it right there, 19.318. That's all you have to do. No bother filling in the formula. Don't bother doing any of that. All right, then I need to find the distribution picture here. So I'm going to have to draw the chi-square distribution and label the 19.318 and my p-value, which is less than 0.0001. So I'll be right back with that. All right, so here's the picture right here. Now, you wouldn't necessarily know, but the chi-square degrees of freedom 2 is actually kind of a funky graph. Degrees of freedom 2 looks like this little spike. It's the only chi-square graph that really looks like this. And it's because it's the lowest degrees of freedom you can possibly have. Oh, I guess you can have 1, but it's very, very, very small. Anyway, my point is that it's this weird one. So if you wouldn't necessarily know it's the weird one, if you just drew the regular chi-square curve you used to, that's fine. But you want to put 19.318 way far out. Honestly, it's not even this close. This is more like 9. 19 would be way over on the other side of the paper. But so you put that down, you label your p-value, and it's approximately 0.000 according to your Minitab output, or less than 0.0001 if you use StatCrunch. Well, either way, it's really, really, really small, and that's all you need to know. Because once you know it's really, really small, as usual, we are going to reject the null hypothesis. I mean, if there's nothing else you've learned, it's that when you have a low, low p-value, you reject, and that's a good thing. In general, we're trying to prove our claims. We're trying to prove our alternative hypotheses. So you want your p-values low, and the lower the better. Of course, it's not actually 0.000, it's about 0.000. So it's, probably like 7 decimal places of zeros and then a number. But when we reject the null hypothesis, that means that there is enough evidence to support the claim that there's a significant difference between boys and girls TV show preferences. And I don't think that's shocking to anybody that works with young boys and girls to know that they like different things sometimes. All right, we are all done with chapter 12.